values. So you know that this one you get you the YZ, right? YZ. This one will get you the XZ. So how do you write this term? Like there is a delay by 1, delay by 2, sometimes y plus 3, let's say. There's another term, let's say. So how do I write the YZ? Okay, so this one you have to refer to the properties of the Z transforms. Okay, so if you have a delay, right? Time shifting, right? So if you have time shifting properties, okay, how do you need to write your XZ, right? So you xn minus k, so how do you need to write your XZ? So you need to, if you have a delay of minus k, then you have to add a multiplication of Z to the minus k, right? So in other words, in this exam, you will need to use another table to write this. Multiply with Z minus 1. Okay. Why there is this Z minus 1? Because you have a delay of minus 1. So here there's a delay of minus 2. So you have you need to write YZ multiplied with Z to the power of minus 2. Okay, so that's your HZ lah. So HZ meaning that you need to find one output divided by input lah. Okay, so you need to rearrange this and see what is the term. Then you got this lah. Okay. And then from HZ to HN, okay, so there is many things, and then there's normally you need to use table, okay, and sometimes you need to do the partial, what do you call it? Partial fractions, right? Sometimes you need to use the partial fractions. Okay, partial fractions. Right. Okay, right. So let's say you got this HZ equals to 1 over something now. So because the table doesn't have this form, right? If you check the table, how do I get, do the inverse Z transform for HZ, because table doesn't have this form. So you need to do partial fractions. Okay, first step, eliminate the negative power, and then divide both sides by Z. Okay, after that, do the partial fraction expansion by cover-up methods. Okay, so you got it like this. Make all the Z become negative again. Then you can see that the first term and the second term, you can use table to find what is the xn. Okay, so for this case, you need to use the partial fraction method, right? Maybe, right? So I didn't go through the steps. So to arrive at this answer. Okay, any questions about this? Right? Anything that I didn't cover? This is question 2A.
Yeah, I think it's more clear.
Okay, thanks.
Okay, thanks.
So we move to the next question. This question is 5C.
So actually for question 3, can you help me check that?
Question 3.
Can you just scroll down? Yeah, for this LTI system, right? What I got for the HN is 1, 2, 3, 1 is correct.
Oh, how do you write the HN, right?
Yeah.
Yeah. Okay, so this one is 1, right? So this one is n minus 1. So 0 and 1. So there is a 2 here. This one is 0, 1, 2. So there is a value of 3. 1, 2, 3. So you add these 3 elements together, right? So there's HN is 1, 2, and 3. So negative move to right. Yes, it's correct. Positive move to left is correct. Okay, but in the exam, you don't. You should say negative. So if it's negative, so it means that delay. Right. But in your heart, you should remember it is moving to the right side. Okay? But in the exam, you write these correct words. So positive means advanced. Right, advanced. And what else you need to see?
Yeah, because for the
Mm.
3P is that determine the output of system DFT. So 4 points. So for the HN, I must add one more number for it, right?
Yes. You must add zero lah.
Or zero, so not
Ah.
one.
No. You add zero.
Or at zero. Okay.
Yeah. So because the question is you have only 3 value here, but you need to do 4 point. How do? You have to add one more zero here lah. Okay. Append a zero. So it is 1, 2, 3, 0 lah.
Okay, got it.
Okay. This one number a zero. So this one okay. So it's not. Okay. So this one should be 0. Okay. So there's some sketches also. Cut off frequency. Okay, assume done AB. Okay, so assume done. Using this to determine. Okay, wait. This is what is the question? What is the equation for? Let's say equation for the filter design. Butterworth.
Oh, by the way, so the formula will be given during exam, right?
Yes. If you check my past here, the equation is at the back of the question.
Yeah. Okay.
Okay. Right. So I think the equations. Oh, okay. So yeah. So this is 1 plus. I thought it is a H. Right, so this is a 1 plus. Using this, okay, to determine H.
To determine N.
To determine N or N. This is N.
Yeah.
Okay. All right. So in the steps, I don't write this. I might thought that you don't understand. So when you're trying to find HS, if when I look at this statement, okay, this one I can help I can. I know you must be maybe writing not so. Maybe this too near to the one, but this one I would thought you are trying to look for this. So I might misunderstood. Okay, so this one assume done. Okay, so you got the N, you got the omega P. Okay, right. So transform the analogs HS. Okay, so you need to know what is HS now. Okay, to a low pass digital filter HZ. Okay, so there are few ways to do this. You can use impulse invariance method, or you can use bilinear transformation. Both of these equation, you need to know what is the TS and the sampling interval, and it is given, right? So that's good. So good that it's given. No need to estimate by ourselves. Okay, so let's look. Oh, okay. So you decided to use this. That's all right. Okay. So this is the relationship between omega analog frequency and the digital frequency, right? Okay. So this is the small letter omega, right? So and then this is the TS, right? Okay. How to find what is this?
Oh no, I just read out how to find HZ. So for this equation, I just do the substitution or what?
Yes, substitution only.
All right.
Yeah, both of these just substitution. So nothing very difficult actually here.
Okay.
Equation given, then you just need to change S to Z. Okay. Yeah, there's so normally these equations is for us to determine this. So I think in this question, you do not need to worry about need to use this equation in this question, but because it's given. Because analog, so this when you design Butterworth filters or Chebyshev filters, okay, normally specification already given. right? So it's already given this. We have some informations on the capital omega, right? So this one generally is okay. You know what it is. This one you normally would know that it must be between minus pi to pi. Right? So what you need to determine is, okay, so how do I decide my sampling interval? Okay, but if the question is already given, then all right, so you don't need to worry about this equation, right? So to find question 4C, I think no need because it's given. Right, so what you need to do is just substitution only lah. So this one is a very simple question. So it's the substitution, right? So there's an equation for these two lah, right?
All right, understand.
Okay. So next is good that you arrange easy for me to track lah. So this is a very good way to present the question to me. So I don't need to headache confused. Okay. So let me scroll down a little bit more. I didn't any more. Yeah.
Actually, for the question 5C, it relate with the 5B, right?
Based on the spectrum, yeah. So you need to see what is B and find an FRR filters with ending window M41 such that the original signal can be restored. Oh, okay. So what happened in B is that the it has been downsample and upsample. Okay. So here the spectrum. So you need to find what is the spectrum is in terms of X F or X omega lah. Right. So you need to do a DT FT. Okay, so you have some spectrum. Okay. Is it given? Oh, you don't need to calculate. So it's given. Right. It's a triangle spectrum. Okay, with this length. So what happened to this X omega go through a downsampler is that it will be expanded. Okay. Then upsampling, it will be shrink. Okay. It will be expanded twice and shrink 3 times. Okay. By factor of 3 lah. And then this is your Y omega, right? Okay, so you need to sketch what happened to V omega and what happened to Y omega. Okay, so if you wanted to restore the signal, okay, so you need to let's say you got this some maybe after you shrink, maybe it's like this. Okay, so some of the aliases come into your minus pi to pi, right? So you need to design a low pass filters to extract out the triangle. Okay, so because the original spectrum is a triangle, so you do not want anything here, you do not want anything here. Okay, so you wanted to design a low pass filters. So you need to design FIR filters with Hamming window. Right. So in the slides, chapter 4.1, we are using rectangular window as an example. But in this case, you need to know how to use the Hamming window, okay, to extract out, how to design these low pass filters. Design low pass filter with Hamming window. FIR low pass filter with Hamming. All right. So you need to know the specification of the Hn. Okay, what is the value of the Hn? Okay, of these FIR filters. Okay. Okay or not this one?
Oh, okay. FIR filter.
Yeah, FIR filter design is a low pass lah. So the problem is that where is this omega c, right? Where is this omega c? So that's the design question. Right.
Okay. Okay. After I tried it out, can I send you my answer to have a check?
I only check your steps lah.
Okay, all right, can.
Okay.
Okay.
Okay, so that's all. Okay, what else I need to see? Okay, number 2, or even number 2. Okay. Uh, can you list down the steps on how to get the correct answer? Okay, so there is December. Okay, so this all I need to check lah. December 2021. First we check December 2021. This one, right? Okay. Oh, these are all the questions. Number 3. Okay, so this is the question set.
Yeah,
Okay.
these are all the questions. Yeah.
Okay.
And that one is my answer.
Your answer. All right. Okay. So, okay. So, past year, right? Okay. So you can, if you can write this down, different equations, then should be okay lah. Let me see, right? So there's a yn. So you see, there's a yn. Okay, so there is a 1.5 of yn. So do you have that? Do you have this 1.5 of yn? Macam tak ada. Okay, let me see. xn 0.05 of xn. Do you have that? 0.4. So you see what happened if I follow the diagram now. Xn multiplies 0.05. So here you got 0.05 xn. Okay. And then what is coming back in is this point here is minus 0.5 yn. So add them together. Then delay together. So you got minus 1 and minus 1. Okay. So, and then also you have to delay another time. Oh, this one very complex. Let me see the questions. 2 October 2021. So this one. Okay. Make it bigger. Okay. Okay, so how come this becoming this? Okay, let me tell you what's happened here. Okay, first, this question is chapter 1.2. Okay, difference equation, right? Difference equation. Okay. Okay. Look at these slides. Are they the same? Right. This is yeah, this one and this one in the slide lah. Okay, same, right? So if you know how to do these slides, then you should be able to do how to do this slide lah. This question lah. Is in the answer is here, right? Just a little bit of value change lah. This is 0.5, then in the exam is 0.05 lah. Okay, so this one.
Oh, so okay, just refer back this slide.
Come back to this slide, then corner pick, and then think about it lah. How do you get to get the answer? I just modify a little bit from the side also. Okay.
Okay.
Okay. So this one I don't understand already. This one very complex. hard to follow. Okay, so I just skip that. So this one, I think something wrong already. Okay. So the next question is
Oh,
proposed.
so I think what is the problem already? Yeah, the question you're looking at is the December 2021, but my answer is October 2021.
Oh, okay,
Ah,
okay.
yeah.
So I'm looking at the wrong one.
That's the wrong one. I think you this one is October.
Okay, so I should close this. So don't close this one.
Yeah.
I go to December. So
This one December.
December. Oh, sorry about that. Swabuka. This one. Oh, I should
Yeah.
open this.
Yeah, you open try.
Open this one. Okay.
This one is the question. I think I got attached the answer.
Okay.
Yeah.
Answer is this one.
Yeah, this one.
Oh, okay, okay. This one.
Yeah, this one. Correct.
Okay. Roughly check now. Okay. This one should be correct lah, because I see there's a delay of xn. Okay lah, delay. This one multiply and delay of y. Okay, so this one all right. So propose an equivalent system function in the form of, good that you show this so I don't need to roll back to see. Equivalent system function in the form of impulse response, so Hn, okay, through Z transform methods. So meaning that this difference equation, you can do the Z transform first. Okay, so make them into Z transforms. Okay, then after that, inverse Z transform to get your Hn. Okay, so let's say you know this lah, right? This one you write it to me already. So it is Hz is equals to this. So I consider you understand. Let's say you got this. Okay.
This is my own notes. I just write down, refer to the tutorial.
Okay. Okay. So this one from here, you do a separation between the two like this lah. It's not so correct lah. Okay. So yeah, then there's a calculation mistake here. Okay. It is mathematically wrong if you so this is the denominator, right? So you write one denominator here and another denominator here. And then this one, you write it here. One, you write it here. You shouldn't do this. This is mathematically wrong from here to here. The right way is, let me see. It's correct. Yeah, you are correct. Then from here, you start to look for, okay. I see the problem already. Okay. What I expect here is you do partial fraction already. Okay, so you will run yourself into a difficult situation if you start to find out how to inverse transform this hz to hn. Okay, so at this point, you need to do partial fractions steps already. So meaning that remove the negative z power, move one, divide both sides by z, okay, and then do cover methods, okay, to find a very comfortable form of equation. So you have to refer to the steps here. Oh, okay. PowerPoint. So I think I have history. Okay. The transform here. Oops. Okay, you need to study this, right? Okay. Z transform partial fractions. Okay. Step 1, step 2, step 3. get into this stage, then you can do the inverse Z transform by table already. Okay, so if you start off, if you, yeah, so let's say this is your first term, and then this is your second term, then you started to figure out how do you do the inverse Z transform. Not difficult lah. You see, so there's a Z here, and somehow you put it out here. Let me see. And then you write this. Then you write the other one. Oh, okay, I see what you do. You have a delay. Okay, then this one you can write it as the, okay. Okay, I think you are correct. You find another way to get the answer, right? You find a way to get the answer. Okay. To further confirm your question is correct. This is the first method, right? You do that I normally ask them to do partial fractions, then to get your final HN. And if you go through this way and get your HN, no, most likely your H0 value, H1 value, H2 value is the same as the answer here. Even though the expression is different, if they are the same, then you are correct. Okay. And I'll see maybe you are correct. So I will check that, and if you are correct, then I'll give you full marks also. Okay, so there's no, if let's say you don't go through this and somehow you find your way, got the answer, you also get full marks. This one is correct, this one is correct, and then this one is also correct, then you should get full marks. Okay, so that's my opinion for your working here. Proof that the system is stable. Okay. Okay, so let's say you got this, and then you are able to plot this one, roots of denominators. Okay, where Z is also, so I don't go through the steps here because I need to think. Okay, so let's say you are able to plot this okay, and you found that the roots is inside the unit circle okay, and you show me what is the zero and poles. Okay, this is the poles. Is it? This is a zero, right? Okay, then you say, okay, the system is stable. Yeah, is stable. But yeah, and you also say Z is within the unit circle. Okay, so this question also all right. The idea here, I can see that if the post is within the unit circle, then the system is stable. Okay, and you show all the possible roots for the numerator and denominator. Yeah, so that's all right. So it should be full marks.
Sir, actually for the how to determine the stable is the point within the circle, right?
Yes, it's this cross that this pole.
Okay.
Must be within this circle.
If 1 equal to 1 is partially stable.
Yes. This one you can refer to the slides here that transforms. Okay. Stability. Okay. Transform stability. It's stable. Right. Okay, so this slide says if the pole is inside the unit circle, the signal is stable, right? So if the pole is on the unit circle, then it is marginally stable, or it can be unstable. If it is double pole, then it will be unstable. If it is single pole, then it is marginally stable. Right? If it's outside, then it is unstable. So we refer to this slide to determine whether the system is stable or unstable. Okay, so this is stable system decaying because it's inside. Okay, marginally stable and unstable. Right? So yeah, there's another very important statement here. If a pole of the system is outside of the unit circle, the system is unstable. Okay? So we come back to this slide and determine our clan. Okay, so the crucial parameter in the block diagram is circle parameters. Okay. Okay, so this is the questions on, okay. So you say that if I adjust this to this, then the hash Z will having this, which is located in this. Okay. So from these difference equations, right, you are able to deduce the hash Z. Right, from difference equation to hash Z, I think everyone's by now should know how to do lah. Okay, difference equations. Then from hash Z, you are able to see where is the pole location, and you know which pole is making your system unstable. All right, so you have pole number 1, number 2, number 3, let's say, and since you know the pole locations is making your system unstable, you could track back. Okay, actually this pole is related to which item here? This one? Is it because of this one? Is it because of this element? Okay, you can trace back. Okay, so we see which of the system values that you need to readjust so that your hash Z pole to become stable. Right, so let's say you need to change 0.5, say 0.5, or you are decided to change this, make it to 1, then you can avoid the system to be unstable. So let's say I don't have the scheme, marking scheme. If this one make your hash Z, okay, and making your, you can make the working step now. It is making my new hash Z to become this, and my pole 0 diagram is this, and every pole is inside within the unit circle, then system is stable. Okay, so this is what you if that's the case, then you are getting full marks. Okay, so you are decided to change this value, right? Okay, I think your answers is correct. I didn't go through the very detailed check now because of the time now. Okay, right. So this one, all right. Okay, this is first digit. Determine the system output by performing circular convolutions. Okay, use the matrix method. That's okay, and you add a 0 here. Okay. Prove that the sequence yn is the same as the found in by using Fourier transform DFT. Okay, so you use this is your W4, and the fact that you can see your mind is doing this lah. Okay, then you are trying to figure out what is the value here, and the value here you stated clearly here already for me. Okay, so I know that you are substituting this into your matrix. So you got this. Okay, all the steps are clear. You multiply xyn with the W4 to get your x1k. And this is your x1k. This is your x2k, right? This is your x2k. And then you are multiplying it, and you got this your yk. After that, you do the inverse, right? So you do it inverse, and I will check whether this is conjugated. And you finally got this form, and it go back to 8566 now. Okay, so if let's say every steps I saw your calculations is all right, your concept is right, then you are getting full marks now. Okay, the next one, prototype analog Butterworth low pass filter with specification given as follow. Okay. All right, so you are using Butterworth, right? Low pass filters, and it is analog Butterworth. Okay, and you say that this is omega p. I can accept that normally omega p is in radian per second, right? So you need to multiply it with 2 pi, then only you can say that it is omega p. Okay, so this one I have to multiply with 2 pi also. But if you don't multiply, I'll just close one eye also. Right? And then if your equation is wrong, then that might be Normally this one I let go now. So if you say this 1,000 first is your omega p, normally it's okay, because you see, if you put in omega p here, and then this is your omega c, for example, or here, this is your omega s, and then this is your omega p. If you divide omega s with omega p, the 2 pi will eventually cancel off also. So you can do is 4,000 divided by 1,000 is still okay, because it is a division. So the 2 pi is like no need to be there, extra steps. So normally I'll just say okay. Oh, okay, so you got done this. Yeah, so this is the correct way. So you to name this correctly is like this, multiply to 2k, 2 pi. But if you didn't and you put into the equation, I would say it's still okay. Right. Okay, so this one, it shows that you really taking in all the detail. Okay. So I must reward you if you are very careful on all the notations. The concept is clear. Okay. All right, so then you remember there's a negative, okay, and then you've got about this, okay. You will find that this epsilon values 0.5089, 0.259 is from the tutorial also, right? Okay, so yeah, okay, so there's a mark here, ask 40 dB equals to 10 log this. Right, so this one you has, okay, so the omega here, you should replace it with omega s, and 40 dB you should put a negative. Okay.
Oh, why should you put the negative?
Because attenuation.
Attenuation. Okay.
Yeah. Okay. So this is 30.
All right.
Okay. We put 40 here, but it should be. So attenuation is negative. If you do positive, it means that it is an amplification.
Oh, okay.
Positive means amplification. So semua salah lah. Okay. But okay. So let's say you forgot a negative here. Firstly, I would think that okay, you don't understand what is attenuation. Okay. But all your steps here is correct, because the step is correct, just that you are using a wrong value here all the way down. So you will not die here. Okay. All this will not die. Okay. I will still give you the steps here because you are doing the algebra correctly and you know how to get the n out actually. So your n might be wrong, maybe, okay, because of the negative. Let's say now. So you will lose the mark here, and you will lose the mark, the concept wrongs marks here, but the steps I will still give you marks, right? So that's the idea. Okay, next one, derive the function hs for the low pass filters. Okay, you need to know hs for Butterworth. You use this method. Itu betul lah. Okay, so you got how many? Okay, and let's say n equals to 4, right? So your sk is 0, 1, 2, 3. Okay, betul. Okay, so this is correct. So you got this. Okay, yeah, correct. So if the step is correct lah. I didn't check the answer lah. The step is correct. Because if your answer is also correct, then you are full marks. Okay. So if let's say you say that okay, in the previous here, because of my mistake, I get my n equals to 4. Let's say lah, and actually this is not the correct n. Let's say this is not the correct n. If I recalculate with a negative here, maybe I got n equals to 3 or 2. Okay, if I use n equals to 4 in my next question here, and my final answer is because of the n equals to 4, I got it wrong, would I be penalized? I would say in this case, normally I would give full marks. Okay, because I already penalized you for a wrong n here. Okay, so here, because you thought that your n is correct, you do it here. You use your n equals to 4 here, okay, and then you got the wrong answer here, but I cannot penalize again for the wrong n equals to 4 use here because I already penalized in the past question. So in this case, if all the steps are correct, then I should give you full mark. Okay, so that's how I mark. Actually, I mark very lenient. Okay, I don't penalize you for wrong values used in the next question. Okay. Digital equivalent filter. Okay, so this is bilinear transformation. Okay, so from HZ to HS lah, right? So you are using bilinear transformation lah. And then you have this omega p equals to pi divided by 4. Okay, so this one, you need to use this. Yeah, lah, you need to use this already lah. Okay, so this one is pi divided by 4. Okay, and then this is the past tense. Okay, then you should know what is your t lah. Yeah lah. Okay, correct. So if you use this to calculate your t, then you got. But I didn't calculate what is the. I didn't use calculator lah, but the step is correct lah. Substitute. No need to simplify. Okay, that's the question. That's the answer. Okay, so that I think your past year do it quite well lah. Okay, so given d equals to 8. Okay, so it's downsample. Okay, so this is the question number 4. Then you have downsampling already. Design the FIR lor. Okay, so this is the FIR filters. Okay, with rectangular window. Length m equals to 11. Okay, so this one is all right. Let me see. This is not rectangular window. This is a rectangular window equation. Rectangular window is O1, so I think there's something wrong here already lah. Okay, something wrong here. Okay, so what I expect from this question is the design of FIR filters. Okay, so you need to refer to the slide how to design the FIR filters. It's like this. So you have HD omega, HD omega, right? Yeah. Then you find your HD omega. This is a sinc function. Okay. So there is a inverse DTFT process here. Okay. So you need to show to do the IDTFT, including how to do the integrations and so on. Okay. Cannot skip lah. Okay. Cannot directly take the answer. You have to do the formal complete steps. Then after you do this, then you have to multiply it with your window, right? You multiply it with a rectangular window. Then you got your HN. And this is the answer already. Okay. So you because here you say m equals to 11. So you need to list out what is H0, what is H1, and H minus 1, H2, H minus 2, they are the same value and so on until Hn. And let's say H5 and H minus 5, they are the same value. Okay, so this is not causal yet because I see that you need a causal FIR, right? So if a causal FIR, then you have to shift this, time shifting it to Hn minus 5. Okay, so every element it is at the right side of the graph, and that's it. Okay, so yeah, so I think this is wrong already. Using some other window. Can follow me this one? How to design FIR filters?
Yeah, I'm figuring. So I don't have to use this formula lah.
No, because rectangular window you do not need to use this formula. Let me check. Let me see what is the filter design technique here. Chapter 4.1, right? Okay, so you have some formula here, right? The table, right? Okay, you are which one? I got cosine one. Batman, you're using Batman, isn't it? What is the cosine 2 part n divided by n minus 1? Hamming. Or this Hamming. Hamming. 1 minus or you are using Henning. Okay, so you are using Henning, but the question asks you to use uh, rectangular lah, right? So what actually happened is that at this step, you can decide. Okay, at this step here, this is the window, ma. So you can decide whether you wanted to multiply it with a rectangular window, or you want to multiply it with a Henning window, and so on. So this is the part that do you want to use the equation lah. It's for the multiplication. Okay. All right. So in this case, the question asked is rectangular lah. So you are using a wrong window lah. Okay. Tak betul lah this window. Doesn't answer the question lah. Okay, next page. Given the linear system with the input xn and output of yn and initial condition below. Okay, calculate the system response. Okay, let me see. What is this?
Sorry, for the previous question, so what situation I will be using the Henning equation for that?
Okay. When I ask, okay, when I ask you to use Henning, then you should use Henning.
Oh, because this Henning equation is I got from the formula attached for the you given the formula one.
I given the formula.
Yeah, from the like previous
Okay.
exam.
Maybe we look at the question again now. Is it this one?
Okay.
Okay, let's see. Question. Oh, with rectangular window. Okay. Like the current, there's no Hemming here.
Oh, so which mean if you didn't state Henning, I don't need to use Henning equation
No.
Okay, okay, okay.
I asked you to
Alright.
use rectangular window. Right. So
Okay,
then
okay.
you have to read the question carefully lah. Okay. So this one maybe some misunderstood now. Okay. So okay, revision this one. Okay. Okay, so this is the difference equation. And then calculate Hn. Okay. So this one is also same lah. Difference equation, you find what is Hz, then you find what is Hn, right? And determine the causality of the system. Okay, to see where, so you can read from here to see whether it is causal or not causal lah. Causal means you doesn't have future value lah, right? So in this case, this is causal. Okay. Sketch the block diagram described by this linear system. Okay. Calculate the zero state response and compute y. Oh, this is this looks like it looks like the tutorial questions or the example in the this in the slides, is it?
Yeah, I think it's more similar like that.
Yeah. Okay. Okay, so let me see. Impulse response. Okay. We do the okay, so you do like this. Okay. Difference equation, you get the Z transforms. Then you do this. Then you separate them. And so what happened to this term there? 0.5 is here. Okay, here I don't understand. Okay, maybe from here to here got problem now. Okay. I'm not sure. Maybe this is wrong now. Maybe because from here, from this term to this term, maybe it's not correct lah. Do you think so? Divided by Z. Wait, divided by Z minus 1. So you are divided by Z minus 1. Okay, here also divided by z minus 1. So you got z minus 1 here. Okay. Then 0.5 at the outside. Okay, correct. Oh. So if you think this way, is correct. Okay. And then from here, you got, okay, then you got this. So this one you settle already. Okay. Okay, so maybe you are right. Okay, be all right. Okay, so you are using a extraordinary way again. Okay. I cannot say you are wrong, you should be correct. Okay. Okay. Maybe the questions that I've given, there's a multiple way of doing it. So normally I expect them to go through the partial fractions method. But meaning that we will change this to positive step and follow the steps that in the partial fraction slides. Okay, then normally if you go through that slides, that steps, normally will not have problem. But looking at this, you should be correct. And I will calculate. So how do I check? I will see what is your H0 value, H1 value, H2 value, let's say. And so if they are the same with my answer, then you are correct. Okay. So determine the causality. Only the present and the past. Yeah lah. And then you say the system is causal. I also think that it is causal. Okay, then you sketch it, and you got this. Okay. Correct. Okay, so you see, I actually reuse back the slides now. Okay, so this is the zero step response. Okay. Calculate the zero state response. Okay. So this one is, you can refer to this slide for how to do this question. It is zero state. Zero state is, I think here, 1.2. Okay. Zero state. Right. So, for example, okay, so the system is at zero states, and the corresponding output is called the zero state response. Okay, the system is initially relaxed at time n equals 0, and the output of the base should be 0, hence y minus 1 equals 0. Okay, so in that case, zero state response. So I need to rethink again on this question. Okay, according to these definitions, y minus 1 equals 0 lah. So this is the important idea here lah. Okay. Start with 0 initial condition. Okay, so let's see what we do. Okay, calculate the zero state step response. Yeah lah, correct lah. So this is un lah. This means this is un, and then your y some minus n minus k. All these values are 0 lah. Okay, are you doing that? Okay, so this is initially relaxed. Okay, for step response, this one equal to 0. Okay, this one equals to 1. Okay, so if n equals 0 lah, n equals to 0, then you can assume that lah. Okay. All right. Okay. So the question, calculate the zero state step response. Okay. So first of all, this one you make it into 0. Okay. Then you've got this. And then the fact that there's no value, this one is 0, then you got this 2xn. Okay, because unit step, right? Because that one, right? So Okay. Yeah, I think. Right. What is this one? Okay. I think you are correct. I think you are correct. You got this, then suddenly you have this. You rewrite this again for zero state equals to 2. Okay, so you got y0 equals to 2. We'll look at what is the questions. Oh, okay, y minus 1 and y0. Oh, okay, yeah, correct. So I see no problem here. Yeah, I see no problem here. Y01, you have given me y minus 1 or not? Okay, actually from here, if okay, so what is the problem with these steps is that the question is asking y minus 1 values and y0 values, right? So they're asking this. Okay. Okay, they're asking this value. And the fact that you already calculate this for me, okay, so I see that maybe I think the steps is correct lah. And then from the working step, I can see that you are actually setting this to be 0 from here to here lah. So if I detect this, then I will say you should be getting full marks lah. Okay, but let's say I didn't detect this then I didn't see that for n equals 0. Let me see. Okay, so this one. Okay, so it should from here to here. Yeah. Okay, so from here to here, you're also showing that y minus 1 equals 0, right? So let's say I did not detect this step from here to here. Let's say I didn't see this. You have a risk that you might get marks deducted because here you're only showing y0 equals to 2. This is hidden, right? Somewhere in the steps. If can, don't do this, okay? Because I might miss it. If I miss it, then you rugi lah. Okay. So if can, write the steps very clearly. Okay. If the question asks you this and this, really go and do the steps for how do you determine y minus 1 and y0. Is it okay?
All right.
Okay. So I if I'm not careful then I have to say sorry. I didn't see it like that. So don't make me into that state. So you have to guide me very carefully from one step to the next. Okay, so actually what happened from here to here. It's also make me mark faster. Okay, so if not, I have to sit and think, what are you doing here? That's kind of painful for me also. Okay, right. Okay, so this working sheet, I think most of the answer in my general comment is that you can answer most of the questions in my past year. Should be no problem. Okay, so what happened to your last exam? I think you are not, all the concept you are getting it correctly. Should be no problem.
Because our last exam is
Physical.
yeah, the physical. So because when I'm doing my midterm is online, so we changed to physical, and also the question I uh didn't solve before for the past year.
Oh, but when you do this past year, all of them are okay.
Don't know.
You can do. I see you can do. It's not that you cannot do. Okay. Right. So this is another one, right? How many? Which one I have done? This one I'm not done yet, right? January 2020. Or I should go to this one. Which one I should go to?
I think it's October 2021.
I should go to this one, right? Okay.
Yeah.
Okay. Okay.
Yeah, I
So
think
this is the question here. I think so.
October 20, yeah, correct.
Okay. Propose the equivalent system function in the form of impulse response Hn. Okay. So first you need to get the difference equation from here. Okay. All right. So what maybe I do from here. So what happened here is there's some feedback. Okay. So let me see. And okay. So so there is one minus 5n here, and there is a 0.05 xn here. They are both go through this delay. Okay. So at this point here, there is 0.05 xn minus 1 plus minus 5 yn minus 1. And then they need to plus again 1.5 and 0.1 of xn. Right? And then they will delay again. Then they will add another 0.4, then you get the one. Oh, okay. All right. So if that's the case, are you doing that? So you have 0.05 delay 2 time minus 0.5 delay 2 time. So wait, so this should be yn, all right? Should be y, isn't it? Okay, because it's coming from here. Okay, so for the second delay is minus 0.1x and 1.5y. Okay, so the last one is 0.4x. Yeah. So maybe here is wrong lah. Should be y lah. Right? I think lah. Okay. So other sikit salah lah. So you put x. So and then maybe all this should be wrong lah. So again, there's a little mistake here. So let me look at the step log. So this one you know. Okay, then you are using long division method. Okay, no problem. Okay. Then what happened here? Here, what is the... Oh, okay. So because of long division, you got this lah. Okay. Then you keep this like this. You separate. Oh, then partial fractions. Okay, you do partial fractions. Then you got your a and b, and then you got this. And then what is the hash n? Okay, so from 0.4 to this one should be a delta n. So there's a little bit of mistake here. Here to here. Here to here. Minus 1 and minus 1. Okay, I think should be correct lah. Yeah, minus 1. So there's a little bit mistake here and there, right? So cannot get full mark because of those mistakes. But I look at your overall steps, should be correct. Okay. Prove that the system is unstable. Okay, so this here. What is this? Oh, okay, so you have this. How about the other? The other pole, did you... Okay, you should mark another pole lah. Okay, maybe here, right? Is it here? Okay. Unstable. Okay, so this marginally stable, you can say, because it's a single pole. So it is a marginally stable, unstable system. Marginally stable system also can, right? So, oh, you got right it here. Okay. So just that little bit mistake here. So I will see whether you got label this or you got label this. Okay, so if you didn't label, there's also marks deducted lah. Okay. All right, so how about this? Consider a sequence x1 and first 6 digit of your student ID. Okay. All right. Okay, so you are doing circular convolutions. Okay, so you add 2 0 here, then you got this. Okay, then after that, you need to do 6-point discrete Fourier transform. Okay, so there is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this one wrong because 6-point discrete Fourier transform, you need to find W6, right? W6, meaning W6. So it is a 6 times 6 matrix. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. But here you got 1, 2, 3, 4, 5, 6, 7, 8. Your 8 point. So by right, this graph, you should separate them into 6 sections. Okay. Okay, you can separate. You must separate into 6 sections, not 8. So this diagram, how do you change this 2 pi into 6 sections? So 2 pi divided by 6 is 1 over 3 pi. 1 over 3 pi is roughly 180 divided by 3 is 60 degree per section. Right? So 60 degree is like this, 60, another 60. Oh, is it like this? This is 120 already. 60, 120, 60, 120, 180. How do you separate the circle with 6 sections? So let me think. 160, 60, and 60. Something like that. Not correct. Okay, need to write down, calculate carefully. Okay. So if you want to section this 2 pi circle into 6 points, so it is 2 pi divided 1.3 pi, which is 60 degree. So the first one is 60 degree, 120 degree, 180 degree, 140 degree, and 1, 2, 3, 4, 5, 300 degree and 360 degree. So 1, 2, 3, 4, 5, 6. So you draw a circle according to this. Okay, so I don't use a circle, and 60, 120, 120 over 90. Okay, 60, 120, 80, 300, and 240. So this one. Okay, so you need to find what is the value here, 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 the value here. 1, 2, 3, 4, 5, 6. Yeah. So you need to use this 6 value put into here. Right, put into here. Okay. Right. So it's not this lah. Looks like you are. Let me see. You are using this, and this, right? What is this? Okay, I need to check whether you are using this now. If you know that you are using these 6 values here, okay, then you should be correct lah. But maybe these are the extra line lah. So I will now I didn't go and check lah. So you might be correct, okay? Because I'm seeing that you are not using 1 over square root 2 plus j1 over square root 2. So if you are using this kind of values, then I know you are sectioning your circle into 8 sections, evenly lah. But the fact that you are not using that, so you are more probably using this 2 pi circle section into 6 sections now. So if you are doing that, then your W6 will be correct. Okay, but I don't check now. Okay, so you got this. Okay, so this is your W6. Then you use your W6 multiply your X1n. Okay, so this is your W6. Okay, then you got this. Okay, you got X2. Okay, then you multiply, okay, then you inverse, okay, then you got this, okay, right. So so if you really got this proven, then you should be full marks. Normally I will check whether your steps are, is there somewhere somewhere there is some students just okay just say proven, but there's some mistake inside here. I will try to detect it using MATLAB. Okay. Okay, so next is Chebyshev filters. Okay, Ripple. Okay, so this one, all right. I think this one you already done it last time. Okay, in the previous past year also, almost similar to this. Okay, so you've got this, then you have minus 0.5. This one you got minus 20, that's all right. And then Chebyshev filters, you use this equation, that's correct. Okay, so this you bring this over lah. Okay. Okay, so you let's say you got it here, then you use this method, then you got your n. Okay, 3.07, make it to 4. Yes. Okay, so you should upgrade it to the higher border lah. Okay, even though it is 3.0, 3.1, 3.01, you also need to upgrade it into 4. Okay. Right. So what is this? Oh, okay. So this is to look for this is beta, right? You are looking for the major axis, minor axis. Then you look for the phi. Then you get all the xy coordinates. Okay. And I check the x coordinate, they are all negative. Y coordinate, they are conjugate. You see, this is conjugate. Conjugate. All right. So seems correct. Then you put because of n equals to 4, you have 1, 2, 3, 4. So I see that it should be correct. Okay. I didn't check the value now, but looking at the step is correct. Okay, digital filters. Okay, so you have this, right? What is your FS, right? Okay. What is the bilinear transformations? So you should be using. Okay, so if you use this method is wrong. Okay, you should use omega equals to 2 divided by t tangent omega divided by 2, right? So you should use this to, let me see. You have HS, HS. Okay. So this one is for you to find what is your FS or TS . Okay, so I see that there's something wrong here something wrong. You should use this if you are using bilinear transformation. Okay, so this one might be wrong. Okay, and then the fact that you replace the Z with the S, the S with the Z, then should be okay lah. All right. Okay, but only the wrong part is here lah. Okay, you should use this. Okay. Okay, number 4. Yeah. FIR filters again, right? With Henning window, right? Okay, so M equals to 41. Okay. So meaning from 0 to 20 lah. Okay lah, correct lah. Okay. Okay. So now there's some problem here you need to take care. So if you look at the slides, if you look at the slides, here. The window. Window. Okay. All right. So if you look at this window, so it says that so this is a causal window, right? So you see it is from 0 until n minus 1. Okay, so it is causal. So you have to what you need to do is when you use this window, first you do this, right? Then you got your HDN, which is a sync function, right? And they are not causal yet because you have a value at the negative side of the graph. So in order to multiply with this Hamming window, okay, you need to shift this first, okay, to the right side. So make this causal, then only you multiply with your Hamming, okay. All right. So that's the idea lah. Okay. So let me see. Okay. So what you need to do here is okay. So you are okay. So you are doing this. This is DTFT, right? It should be no. Okay. EJ omega. You change it to this. Also understand what happened to this XN. We are using from here. Okay, I think this is wrong lah. Okay, this is not so correct lah. Okay, so what you are getting here is a sync function. Okay, when you have the sync function, you are to multiply with this. Okay, so this is your Wn. Okay, right. So you have a sync functions. When you have a sync function, what do you mean? You have a sync function. Okay, you actually can know what is your HD0, HD1, HD2, and so on, and also a HD -1 and so on. Okay. And when you have this equation, what do you mean? When you have this Hamming window, what do you mean? You have your Wn, and you also would know what is your W0, what is your W -1, and W1, W2. Okay, of course, now the Hamming window given in the equations, they are causal. So meaning that they are shifted to the right side by number of n. Okay, so you have to shift this, okay, and so that they can multiply to this one, all right, so that you can multiply both of them. Of course, this is until 40 lah. You don't need to multiply all of them, okay, but you should show the steps to multiply lah. If you decided to calculate all the value here, in fact, another way of doing this is using the expression of HDN multiplied with the expressions of WN. Okay, so that you don't need to calculate each of them. Okay, so let's say you are let's say you decided to show all the values. I think you also do not need to show from 0 until 40 lah, because there's too many. Even though they are symmetric, you just need to show the 20 only, and the other half you can duplicate the value lah. But yeah, so there is two way of doing that lah. Okay, so I think this way is wrong. Okay, so you should go back to the lecture notes. Okay, from the rectangular window formula. I mean, because the lecture notes, the example in the lecture notes is showing you how to use the rectangular window to design FIR filters. Okay, so you have to think. Let's say you have a Hamming window. Okay, how do you use Hamming window to design your FIR filters? Okay. From here, this step is already started off wrong. Right? I see that. Okay. So the rest might be not relevant anymore. Lah. Okay. Okay. Gotlun, is it anything that you wanted me to clarify on your working?
Yeah, I think it's more clear because I don't know whether that I did is wrong, is correct or wrong.
Oh, okay, it's wrong already. You have to study back how to use Hamming. Let's say if you know how to use Hamming window to design,
Okay.
other backmen now you know how to do that.
Okay.
Okay, so this one you do your own research. Okay. All right.
So you're still recording, right?
It's recorded. Yeah.
Okay.
Recorded. Yeah. Okay. So October is done. Is it?
Yeah, well, it's done.
Okay. So December done already.
Yeah, December done already. I think it's just left the January.
January. Okay.
Yeah.
So January. So you do 3 past year now. Okay.
Yeah,
So
3%.
that's sufficient. If can do as many as possible. Okay. January, this one. Okay, last one. Okay. Express the system equation. Okay, again, this is okay. So this is like a tutorial, right? So you add them first, you add these two, and these two add together, and only you convolve, and then multiply, right? Multiply. Okay. So convolutions and multiply is different now. So you got it lah. Okay. So after that, determine the system output if the system is excited with a unit step sequence. Okay. So what happens if this x is un, right? So you need to do the bracket inside here first. Is the hn given? Oh, given. H1, H2 is given. All right, it's given. All right. So you have to add them. You add them. You got H3. Okay. Then you do convolution H3 and xn. Okay. All right. So you add it. Then you use a table method. All right. So to do the convolution between x and h. Okay. Then you got these values. Okay. So it is so you do it quite long enough lah. Okay. So after that, then you just multiply. Okay lah. Right. I see the step is correct. Okay. See the step is correct. So so this is this lah. How about B? Determine the system output if the system is excited. Okay. Determine the output input is changed to this. Okay. All right. Okay. So now, before this xn is un, right? Okay. So I write here now. I write here. Put it right here. So before this is the un. Okay. Then you do all the hard work. Then you get your yn equals to what is this? 1, 2, 3, 3, 3. 1, 2, 3, 3, 3. Okay. So let's say 1, 2, 3, 3, 3. Okay. So let's say now I change this to 2un minus 1. Is it? 2un minus 2. 2un minus 2. Okay, so what happened to my new yn, right? So because this is an LTI system, so my yn would be 2yn minus 2 lah. Okay, so what I need to do is from question 1, so here I multiply it with 2 and I'll delay every one of them by 2 units of time. So that's my answer. But if you want to do the table method also can, just that wasted a little bit of time. But if you look at the answer here, it is multiplied by 2 and there's a delay of 2 units of time. Okay, but still correct lah. If you do this way, still correct. Okay, so this is, I think, question 1. All right, no problem. You can do. Okay, so then you go on to do question 2, right? Okay, again, it is LTI system. Okay, so you know H1, H2, H3, H4. Okay, so this is the same. This is a tutorial question, right? It's a tutorial questions. Determine the exact transform. So this is a tutorial 2, I think. Right? Just that I changed a little. I used the question to do Z transform. So I do Z transforms. So you got it. Okay, so what happened to you change to Z transforms, right? Okay, so if it is so for convolution, it will become multiply in Z transforms. Okay, addition is addition. Okay, so let's say you got this one, if you from tutorial 2, I think you'll be able to write the hash total, right? You'll be able to write the hash total expression. Okay, if you can't remember, just for those who are not sure what is tutorial 2, so the tutorial 2 is here, right? This one. Okay. If you remember how to do these questions, no, the hash 3 and hash 4 should be convolution. Okay, so but if you change h1, h2, h3, h4 into Z transform first, all the convolution will become multiply only. Okay, right? Addition remain as addition, but convolution become a multiplication. Then you can, what you can get is your hash total Z, right? Okay, it's no easy to get now. So let me see what did you do here. H1. Okay. Formula, right? So you have this. This is okay. So this is correct. Okay, from here to here is correct. Using the Z transform table, item number 1. Okay. All right. Then you get your H2 or H3. Okay. H2. Okay. Assume correct now. So I believe you know how to use the table. Okay. Right. Then you get your H4, right? H4. Okay. Looks all right. Okay, so that's the question asked, right? Determine the individual impulse response. Yeah, right. Okay, then overall Z transform system. Okay, so this is H total Z, right? Okay, so this one multiply, minus, then multiply by H1. How about H4? 1, 2, 3, 4. It's all there. Okay, so you do some algebra, then you got something, right? So I don't check this the algebra now. So let's say you got this. Okay. Next is comment this. Okay. Simplified it, right? So you simplified it. Okay. So let's say this is your simplified form. Then you want to check whether it is stable or not, right? So from here to see if it is stable or not, then look at the denominator lah. What is the pole lah? And then you found out where is the pole. So this is the pole. This is the pole. Okay. So then you found that there is a pole at the, what do you call, at the unit circle. So it is marginally stable. Okay lah. So I think your concept are all right lah. Okay, so that's question number 2. Question number 3. 1, 2, 1, 1, 2, 1. Okay, linear. Prove that this one. Okay, so this one, I think it's in the lecture notes. It's in the lecture notes. Okay, proof. This one is symmetric and periodic. Okay, so this one in the lecture notes. Right, so this one, okay lah. Okay, compute 4-point DFT. Okay, then you have 1, 2, 3, 4. Then you got this. Right, then you know how to get this out. Okay. You got this for me to refer. Okay. So I don't know what's this. Okay. All right. So then you got your XK. Okay. So that's it, all right? I think. Oh, okay. So next one. Chevy Chef. Okay. Standard lah. Okay. Find the epsilon. Okay. All right. So got the epsilon. Okay. There's a negative here. Okay. There's a negative here. Okay. So from here you got this, I think, right? Oh, no, I should be using this. Not cos. Okay. So using hyperbolic cos, then you got 6. Okay. What else? C is empty. I C is empty. Okay. IRR filters is to derive from here, is adopted, propose appropriate sampling rate. Okay. So this one you're not sure how to do lah, is it?
Yeah, I'm not sure how to answer this.
It's to find TS lah. You know how to find TS?
Is it the formula like just now you told me
Yeah.
the
Bilinear
oh
transformation lah.
the bilinear the substitute one
Oh, yeah.
okay.
Just the tangent equation counting lah.
Okay. Then I try see.
Okay.
Okay.
Number 5. Okay. All right. Number 5, huh? Minus. Okay. An ideal digital with the transfer function is shown. Okay. Determine the range. Okay. So you are given h prime omega and the h prime n. So you do not need to do the IDTST calculation lah. So it's given by the questions. Normally, if not, you need to show all the steps from here to these questions, to this expression. You need to write all the steps. Okay, and the steps can be found from the lecture notes now. Okay, so now in these particular questions, I give you the answer already. Okay, so you no need to do this step now. Okay, so the question asks, sampling rate is given. Okay, omega c is given. Okay, so here is pi over 6. This is minus pi over 6. So you can write down now the omega c into the h prime already lah, okay, which is pi over 6 lah. Determine the range of analog frequency that falls within the passband range of the ideal filters. Okay. Okay. Determine the range. This one is a bit tougher. The question that I given to you. Okay. All right. So you see, one way to see is that the passband range. Okay. So here, this is the passband range, right? From 0 to pi over 6. Okay. So this is the passband range. Must be smaller than pi over 6. And then the fact that you know what is Fs. All right. So the fact that you know what is the Fs. Okay. So from here, you could know what is the F max. Right? You should know what is the F max by the Nyquist theorem, with the sampling theorem. And then you know what is the, how to say, this is the analog frequency divided equals to sampling frequency divided F divided by Fs. Okay, so this is your analog frequency. Okay, so so what is the range from 0 up to what is the F max lah? Okay, so from here you should be able to answer this question lah. Right? I roughly give you some hints here lah. Okay, so there is a certain range of analog frequency that you can write for this question. Only 5 marks now. You see that? Can you see that? How to get this? How to figure this out?
Oh, okay.
Oh. Right. So these are the things that you need to consider: the Fs, the omega c. Then you should be able to figure out what is the frequency within here. Okay. 2020 FRI filter design, right? Rectangular window, again, same, right? This is 25 values. So this question asks you to find what is the Hn, right? From meaning H0, what is the value? H1, what is the value? Okay, so how to study this? Maybe I point it to you, which is in tutorial. FIR filter design should be tutorial 4. Right, should be on tutorial 4. Right, now design FIR filter. Okay, pi over 6. Right. 25 tab. Okay, so it's your tutorial question. Yeah, so if you have an answer, then you should be able to do your final exam. Yeah, so basically, I'm not killing the student now, okay. Then identify a limitation of FR filter. So this is a disadvantage lah. Right, so you just give some advantage 3 marks, then got it already lah. Yeah, this is the list of formula lah. DTFT, DTFS, Z transform, Butterworth, Chebyshev, I all give to you. Bilinear, this is the bilinear transformations, frequency relationships, impulse invariance I also give. This one not useful for now. Okay, Z transform. Okay, Z transform I only give up to here. The cosine one doesn't need to include it. So window, right? I give you 4 window also, right? This is the window. Okay, so this is the window selection criteria lah. Okay, Butterworth, Chebyshev. This one is the Chebyshev. I got give you Chebyshev polynomial. Okay, then this is the okay. So this is a filter transformations. Okay, that's enough for you to do the task here. Okay. All right. So keep doing my past here would be helpful lah, and also my tutor.
So for my answer 5B is correct lah.
5B. I forgot to help you to check through.
Yeah. Yes.
I give you the idea lah.
Yeah. Okay.
5B. Rectangular window. Okay. So what do you do? Okay. So actually you don't need to do this lah because I already give you the answer now.
Okay.
Right. So then you rectangular from -12 to 12, correct? Actually, correct or not correct, you look at the answer for here lah, number 4. The tutorial 4, question 4.
Tutorial 4, question 4. Okay.
The last question is bulat from here.
Okay.
You can see that. You see this 25 tab. You look at the what is your? We compare the question. Rectangular window, 25 tab, digital FIR. Look at tutorial 4. FIR filters, 25 tab, rectangular window. So satu biji so you can, if you got do tutorial 4, question 4, this one sure you can do right? So unless you didn't practice tutorial lah. So okay.
Okay.
You refer the tutorial 4 answer lah. Okay, this one.
Okay.
Yeah. So this one just write something, then you get the 3 marks. Okay, so Jen, so in the past 3 years we have gone through now. Gone through the past 3 years tutorial. Okay.
So you think it's enough lah for this?
I see you no problem. How can you fail? You all
Well, I think it's the I can't understand the question. I think lah.
Really?
Don't know lah.
For example, let's say let me see actually how it is so confusing. Do you have
Maybe
any?
it's you can refer to the May 2022.
May. Okay, May.
Yeah, for the last semester lah.
Last semester. Okay. So this one now.
Yeah.
Okay.
For this set, I asked you about how to do 1B, right?
Yeah.
Yeah, so I think I can't get the number from the HN lah. Yeah. Because I can't. I just can't because I don't know how to like get the actual number.
Now you know already.
Now I know already. Yeah.
Okay. How come this one n equals 0, then you get this one, this one 0, 0.
Yeah. Because
Oh,
for previous past year, you just give the direct number. So I think some
oh,
question. Yeah.
I'm a little bit surprised. Substituting n only what? Right. Okay. Maybe you just can't see this lah. Oh, maybe like just sometimes we tak terfikir like that lah.
Mm-hmm.
Okay. Okay. I think maybe after I explain, you should be clear lah what I'm
Yeah.
asking. Mm.
Yeah. Much better. Much better. Yeah.
Okay. So maybe some help you can ask lah. Let's say you don't understand the questions, then you can raise your hand, ask the invigilator, can you ask Dr. Yo to come over? I need to, because I'll be the chief invigilator on that day when you take the exam. So you can say, can I ask the chief invigilator? If you see me sitting outside the counter, you can actually ask the invigilator to call me because I have question I don't understand. But if you are asking me, sir, what's this? So I know I won't tell you this one because I assume you would know how to replace n equals to 0 to get one
Yeah.
slot.
This is the basic knowledge of it.
Yeah.
Okay.
So maybe I cannot help you in the exam venue lah. This one. But if let's say my questions, let's say you see there's I think the question asked is really not make sense. I need to clarify with Dr. Yo. You can raise your hand and call me. I will come over and see whether is it my mistake or not. Giving you the wrong statement in the questions. But normally there's a very little chance I give you the wrong statement because before I send this exam for printing, it has been moderated twice. It will go through two lecturers to verify my exam question. So if my lecturers doesn't understand my question, then they already raised to me.
I thought you are I thought for this subject you are only one who teach
Yeah,
this
yeah,
subject only.
yeah. I teach, but my question has to be verified by other lecturer also.
Okay.
So the questions and the answers that from the final exam is I can say it's 100% accurate one. Normally near to 100% accurate because it go through two lecturer checking. So if the two lecturer did not see any problem, so should be no problem to the student. Similar
Okay,
to
understand.
similar to marking also. After I marks, I need another lecturer to help me to check is my marking got problem or not. So normally the final marks is very hard to be curate because we have all these internal process to ensure high quality of the exam questions and marking. So normally we don't simply do the exam one. When we check when we do marking for student, we also very careful. But things like sometimes let's say you don't write your steps carefully. Maybe me and the other lecturer cannot detect it. Then very sorry lah. So the steps you must be very clear to me, like guide me what you are doing. Don't be 嫌麻烦 So let's say
Oh,
I don't have. So you have to tell me. Okay, so the next step I'm doing this. If not, I have to find myself. I scared I also make mistake, and the other lecturer also don't understand. Then gone case.
so I think Ren Jane got some question for
Oh,
you at the chat box. Yeah.
in the chat box. Wait, see.
Yeah.
Oh, your stomach pain. Sorry. But it's recorded. Okay.
Yeah.
Okay. N equals 0, U 0 equals 0. The answer is at n equals 0, U 0 equals to 1. Okay. So how to check this? You can go to my slides, chapter 1.1. Okay. Look at the unit step. Let me find the is it here? Okay. No. Okay, maybe chapter 1.2 lah. Okay, fine. Okay. And so this is the unit step function. Okay. So for n equals 0, okay, there is a value of 1 here. Lah. Okay, Renjian, can you see? Okay. This one. This is yeah, u0 equals to 1. And after that, all of them are 1. Okay, starting from 0. Okay, starting from n equals 0. So it will be a value of 1. So don't make this mistake. Okay, let's see the chat box. Okay, good. Okay, so anything else that you might didn't not clear? So far, I think it's good that Goklun that have done all the three past year and then showed his answer for us lah, so that I can do comment. Okay, helpful for all the class lah. Right.
Hopefully this exam can just pass it.
Yeah. Okay, that's good. I think if I look at my questions, I'm not killing the student because I take some from tutorial, sometimes I take from lecture to get you past. The previous recorded tutorial video. Yes. Give me some time. I need to correct. That's the thing. If Renji, are you in my previous Google Classroom? No, you're not in my previous Google Classroom. Oh, okay. If that's the case, then I go and correct lah. Because take some time. I forgot. In the previous Google Classroom, a lot of how to say the posts. So I need to scroll one by one, and I saw it, and I have to copy the link, things like that. Take some time. Okay, maybe today. Okay, today I go and correct the link for you to see the tutorial. Okay, previous sem one.
So this recording video you also upload, right? For the later on.
Yes, I will also upload into my existing this semester Google Classroom. So if your friend need it, can ask them to join my Google Classroom. I don't mind.
Oh, okay. Thank you, sir.
You can pass the link to them, no problem. To your friends.
All right.
Okay. Okay. Anything else you want to ask? Beside the question past year, all three past year, even prepared by Goklun, very clear. I can see that he spent some time to prepare that so that I don't not so confused lah. And he even write down the question in the answer script so that I don't need to change window all the time. Okay. The rest okay. Student, you don't have any questions so far? My existing student in this semester. Okay. No. Then I guess you are all right now. Well prepared for the question. Okay. I think if let's say you have some question, you still can ask me through email. But normally during weekday my email bursts. I have a lot of email to answer, so maybe I will be reply a little bit slow. You can put in Google Classroom also. I will get notifications from the Google Classroom also, but also a bit slow because I have some daily administration work to do. Some of the time I need to focus on that. But don't be last minute like tomorrow is the exam on midnight 12 o'clock. You ask me some question, maybe I'm not tak sempat lah. So give me 1-2 days. If I didn't reply, then quickly maybe text me things like that. I can try lah, but I cannot give you a full solution already lah. So because I can give you hints okay. I cannot do the question for you lah. That's my limitation here lah. Okay, I wish you all good luck. Do my past year. Okay, January you will be okay. You will see that question 1, 2, 3, 4. The scope is normally there. Like it's always Butterworth, it's always Chevy Chef, it's always that transform, it's always 4-point, 6-point, 8-point DFP. Sometimes you need to know how to do the FFT, right? Things like that lah. Okay, thank you everyone. I wish you good luck in your final exam, and see you again. No, I mean not seeing you again. wish you good luck, and we see you in the campus in the coming final exam.
Okay, thank you, sir. Thanks for spending time for discuss my question.
I think it's good. It's good. Yeah, I
Yeah.
wish all my students do this so that I know where to address the concern. Okay. Okay.
Okay,
See
yeah.
you. Thank you
Yeah,
very
thank you
much.
very much, sir. Yeah, thank you. See you.
Okay. Bye bye.
Bye bye. Thank you.